Okay, hello everyone. How's the weather outside? Pretty fun, right? Let me see if I can get. Let's do a recognition exercise. Who from your table is stuck in the rain right now? Right? That's probably why they're not here, right? Because they're stuck. Okay, so we're all set up. Sorry for that delay. What we're going to do in the first minutes of the class is to walk through or review the answers that you turn in your exit tickets, address any misconceptions that we might still have, and basically have a refresher on what callbacks are and how they work. So, okay, actually for this, could you go to your exit ticket, open it, and see your answers, just so that we verify here what the right answers were, and also, or more importantly, how you could the explanations as to why those are the right answers, and maybe if you turn in the wrong answer, why that is the wrong answer. So that we can analyze more precisely. So let me know once you have your exit ticket open with your answers. You'll find it in the Canvas calendar for that was Saturday, right? Or no, it was Wednesday. Okay. Everyone has their answers? Cool. So from the quiz, Canvas gives us some insight as to how you all responded. So for instance, for the first question, which is select all the code blocks below that will log hello to the console, there were 2 correct answers. 53% of you picked option number 3, and 97% of you, that's 31 people, chose number 2 as a correct answer. So let's look at. So we see that we have 6% that picked the first one, and 16% that picked the last one, and those are not correct answers. So and also, if you have any questions throughout this review, please feel free to raise your hand and let your question be known. So, okay, let's look at first of the correct answers, right? We have, the question is, which one of the following will log hello to the console? So let's see if I can add a little bit more zoom here. Right, I can do this. So we have the correct answers were number 2 and number 3. Or actually, in this case, let's contrast number 2, the options 1 and 2. What is the major difference here? Douglas? One is using the name of the function, as Douglas said, and including the parentheses. The other one is not. What happens when we don't include the parentheses? We just don't invoke the function. Invoking the function requires the parentheses after the name. Otherwise, here you're just saying hello, but the function is never being called. You're just throwing that in the air. We require parentheses always. Okay, let's look at, this was defined in ES6 as we are already familiar with by the function keyword. Let's look at this other example. And I guess in here we could do the same contrast. So again, here the difference is the same one. One includes parentheses, the other one doesn't, right? But here we're doing something else. Who could summarize what we're doing in here that is different from the first example that we saw? Yes, Brianna? Great. It declared a variable, also say hello, and it saved the value of the function say hello into it. Yes?
I have a question. So, let's say hello is a function we don't have to put parentheses with the.
Right here. So Brianna is asking, why don't we use parentheses right after say hello here, right? Is that correct? Right. It doesn't have parentheses because, well, when we use parentheses, we're invoking the function, and we don't want to invoke it yet. We don't want to call the function yet. What we have here in this example is we define a function, say hello, and then this is when we do function say hello, is as if we were declaring a variable say hello that will contain the function. In this case, we are just saying, okay, the function say hello has been declared. Now it's known to JavaScript. Now take that one, say hello, the original one, and save it also in also say hello. So now we end up with 2 copies of say hello. One is the original copy, say hello, and the other one is also say hello. And because also say hello is the same function as say hello, if we call also say hello, then we'll be in turn calling say hello because they are the same function. Any questions about this one? But and then here we're just missing the parentheses again. Okay, let's look at this one. Let's see if I could. Oh. This was, what will the code block below log? We have this piece of code. A variable starts at 0. Then we have a function called n times that is expecting 2 arguments, n and a callback. And what do we call a function that expects a callback? There's a special name that we use for it. Higher order function, that's correct. And then this function is going to do a loop from 0 to 9 according to the for loop. And for each one of those iterations, it's going to call the callback. It's going to invoke the callback. Okay, so let's see. That's the higher order function. Then there is this other function here called increment global variable. It seems to be just doing I++. And if we looked at this function in isolation, we don't know if this is a callback function, right? It will just be another regular function. Now, when we look at the next line, which is call n times, we're passing the number 2 and a function called increment global variable. This is actually what tells us that increment global variable will be used as a callback function. So, okay, so let's look at what's going on here. We have call n times, right? Even the name already gives us a hint. It's going to call callback n times, right? So let's see. Callback n times, we pass in 2 and we pass in the callback increment global variable. So how many times is going to be increment global variable called in this first time? How many times is increment global variable going to be called? I mean, 2 times, right? If we name this function correctly, call n times, we'll make it call 2 times. Okay, and then if we look at increment global variable, we see that is properly named as well. Is incrementing I, and I is in the global variable, right? And then how do we call functions that are reaching outside of themselves? Or not how do we call them, but how do we call that what's going on? I think I heard it here. Hoisting, no. Somebody else. How do we call when a function, what do we say this function has when it's reaching out to the global scope or to outside of itself? Side effect, right? We call when a function is reaching outside of itself to the global scope or to any scope that is not the one in here in these curly brackets, we say that function has a side effect or is performing a side effect. Okay, so we saw that increment global variable is has a side effect, and its side effect is to increment I, and that's it. So in here, if we see that call n times increment global variable will be called 2 times, then what's going to happen to I in the global scope here? What is increment global variable doing? It's incrementing I. And then how many times is increment global variable being called? 2 times, right? So how many times is I going to be incremented? 2 times, right? And we're incrementing by 1 by saying I plus plus. So I will be equal to 2. Correct. Okay. So at the point of execution where we read this line, we have I equal to 2. Now the next line that is going to be executed is call n times, pass in 3, and then increment global variable as the callback. So in this time, how many times is increment global variable going to be called? 3 times. How many times? So if it's invoked 3 times, how many times do we increment I? 3 times. And then I before was 2. Now we're incrementing again by 1 3 times. What is I going to be? 5, right? Because again, this side effect here, that is incrementing a variable outside of the function scope. So in here, when we do console log I, we'll see 5 in the screen, right? So yes. Good question. How does increment global variable here doesn't expect any parameters or arguments, right? And we don't need to pass here. Well, in this case, function function increment global variable is like a sneaky function that is reaching outside of itself. And the only thing that it's doing is incrementing I, right, which is outside of itself. We want to expect parameters when we have a function that will do something with those parameters. In this case, because increment global variable is such a tiny sneaky function, we don't have any parameters that we need or want in this function. Does that make sense? Okay. What was the question again? Right. And guess in the short answer will be because this function doesn't need them. It's not doing anything with them. It's not expecting them. Okay. So on this one, we got 60% of you got that one correct. Some people thought it was going to be 0. So we saw that maybe you thought it was going to be 0 because this variable existed outside, right? And then you didn't really analyze what increment global variable was doing. Or even like, can we have a brave soul that answers 0, remembers why they thought it was 0? This is
16% picture 0 right there.
Say that again?
16% of the people want the 0.
That's correct. I mean, like, and I want to say that like, Pursuit is a space for taking intellectual risks. So you shouldn't feel bad for saying I thought it was 0 because of X. Right? We're not gonna laugh at you, and we all maybe the person who's next to you or somebody else that answers 0 will understand coming from you why it is not 0 and why you thought it was 0. Anybody? Maybe you just saw, okay, variable I is 0 and it's never changing. I'm gonna say 0, right? But again, if you see in here, increment global variable is actually modifying I. Yes, Douglas.
Although I can see that this is one of the very few questions I actually don't like.
Okay.
But I can see how you'd be able to, rather than using error, and that had such an effect on that A1, B1 sort of the problem we had last time, that maybe they're like, oh, it's university on it's tracked at 0.
Okay, so let me see if I get that right. You're speaking about the difference between let and var, right? And that let will be encapsulated, right? Let will be block scope, right? That's what we talked about. But var is not block scoped, and in this case, not only is not block scoped, it is a global variable. So I don't think that fully matches what Douglas said. Yes, Cameron.
If you change the to also about
Here. Oh, this one. Oh, I see. When I console log I here, would I be equal to 2? Right. No. In this case, I will not be equal to 2. So I think then I see now that we have 2 i's, right? One is with var and it's in the global scope, and another one is in the for loop and it's in the function scope. And it's in the function scope. Well, it's not really in the. It's not even in the function scope. It's in the for scope. If I were to console log I under here, like here, I'll get I is undefined or undeclared variable because this I here only exists within this for loop, like in here. Anything outside of here, I doesn't exist. Only the only I that your program will see is the one in global variable. Yes.
So that I function has nothing to do with inside of this increment itself outside of it.
Say that again.
So the I on the inside of the loop has nothing to do with the inside. It's just incrementing itself outside of the loop.
That's correct. Yes. This I here is just incrementing, is being incremented by the for loop, and it only belongs and concerns the for loop. This one is a completely different one.
What happened if you put var?
If I put var in here, now that I will be scoped to the function, so it will be seen outside of the function, or like inside, not outside of the function, inside of the function, inside of the for loop, but not in the global scope. So if we put this let I instead to be var I, that I will still it will not live only inside the for loop. It will live inside the function scope in here. It will live in here, but it will not live in the global scope. In the global scope, we have this other one I. So maybe here the confusion was this I in here, internal, and this global variable. Okay, any other questions about this one? Yes, Michael.
Outside one step.
So Michael is saying, so var will go outside one step. It will go outside one block. But the thing is, like, even this, the function, it will be a technicality, the explanation, that I don't think we have to concern about at the moment, yeah. But like, that's you could see it in that way. For loops, if loops, while statements, yeah. Okay. Any other questions on this one? Let's see question 3. Actually, and then maybe in this one, maybe people got confused also because a mistake on my end, which is you can select multiple ones. But in this one, there's actually only one that's correct, and it's 5. So, cool. So let's look at the last one. Given a function number changer below, which of the following are written using valid JavaScript syntax? So let's look at the statistics on this one. We have 4 correct answers in this one, and we have some outliers. I think most of you got it right. We have some outliers on answer 2 and 5, and some people didn't respond. So let's look at this one. We have a function number changer is declared in the variable is declared in ES6, right? The function expression is using the function keyword, is therefore being declared in ES5, right? We're just saving this function, we're saving it into the constant number changer. Okay, so let's look at this function. It's expecting a number and a callback, and it's going to return the result of calling the callback with that number. Okay, so let's look at the options that we have. So which one we're seeing, which one is valid JavaScript syntax? Okay, so we have number changer, and then we have parentheses, so that means we are trying to invoke the function. We're passing in number, the number 5, that will become this number right here, right? And then we are passing in a function, this side, right? Do we, thumbs up if you agree that this is a function? Okay. Thumbs middle or down if you don't agree that this is a function. Okay, so we got some thumbs up, but we didn't get thumbs down. So that means there are some people in the middle. So let's try to see. So this is indeed a function. What kind of function is this? ES6. What else? Yes, that's correct. How do we? There's another kind of name that we have for functions in ES6. I mean, again, implicit return. Not in this case. This function has implicit return, but I'm looking for another kind of name for an ES6 function. This is an anonymous function. That's correct, Ohidur. A fat arrow function. So we named it an ES6 function and also a fat arrow and an arrow function. And Amin and Deja mentioned two characteristics of them. One is, or of this one specifically, one is the implicit return here, because we're not using the return keyword, and because this is a function with only one statement, which is multiply num times 2. And Deja, what was an anonymous function as well, because this function is doesn't have any name, right? Therefore, it's anonymous. Okay, so this is indeed a valid answer. So, any questions here? Cool. Let's look at the next one. Number changer. Syntax, and then in this case this will be invalid syntax because again we're mixing both of them. So we either go with function and square brackets, not square brackets, curly brackets, or we go without the function and the arrow. Right? If we remove the function keyword here, we just end up with whatever we have in the previous answer, right? Okay, let's look at number changer 5, and we're declaring a function with ES5 syntax. That function is expecting a number and is going to return that number times 2. Is this valid JavaScript syntax? Yes, right? We don't see any weird mixing here. We have good old ES5 syntax. Cool. So let's look at the fourth option. Number changer 5, and then we have this that looks like an ES6 anonymous function, and is returning num times 2. What do we think about this one? Douglas?
Because it returns something, regulated. Works above without.
I think you're down the right path. What is the difference between this function and the first option? It's along the lines of what Amin said, one of the characteristics. Michael? Yes, but what do we call when we don't use the curly brackets? Implicit return. And here we have implicit return. The JavaScript is so smart that it knows that you want to return num times 2. In this you're asking explicitly to return those, and you're just wrapping that in the regular body of the function with curly brackets, denoted by the curly brackets. So here, the only difference between the number option 1 and option 4 is just that it's still an anonymous function, but now we have an explicit return in here. Other than that, JavaScript will treat them equally, the same function. Okay, let's look at this one. What do we have here again? Giselle, what do you think? That's correct. We're mixing again ES5 and EX6. And I remember the arrow is kind of what tells JavaScript that is a function that it's going to be looking at. So here we could think that we'll be redundant saying function and then that arrow again. Okay, now let's look at this last one, number changer. We're passing in 5, and we're passing in a callback function. That function is expecting a number, and it's going to return the number times 2. Is this valid syntax? Why? It's ES5, and it's returning the number times 2, right? In this case, we have ES5 here, we have ES6 here, and also some of you might get confused by the fact that, for instance, this function, or for instance, this function is the same one as the last one. Let's see if I can get them together. Yeah, this one highlighted is the same one as the last one. Yes. Wait, I'm sorry, I cannot hear you correct. Oh, thank you. I know why this is being deprecated and it's not going to be available after August 1st. We'll just try to find another way. Thank you. Okay, so again, this function is the same one as the last one. What is the only difference? And it's a difference to us, not to the computer at all. Last one and this one is the same function. There is only one difference, and that difference concerns only us humans, not the computer. Suzette. Right, the return is on its own line, but we still have the same. We have curly brackets wrapping the return and the last parentheses. It's just that we broke it down into multiple lines, but we still have the same function. And to JavaScript, it doesn't matter if you write a program in one line. It will just be really hard for another human to understand your program, but JavaScript will still run it. Cool. Any questions? Okay. Let's jump into the topic that concerns us today, which is array methods. And array methods, wait, raise your hand if you read the lecture notes before coming today. Okay, thank you. I hope that number keeps growing. I mean, I cannot stress enough how important it is that you have a preconception, that you read some terms that they are stored in your brain, and then when we come here, we exercise them, and then your learning will be more complete, will be easier. And again, if you if you come only to what I'm saying here, you're missing stuff that I might forget, stuff that I took out of my lesson plan because I didn't consider that I had time for explaining. But if you read the lesson, at least you have an idea of what that is. Okay, so array methods. So we have already been using some array methods and the like. What are some of those? Car? That split. Is that an array method or other type method? String methods, sorry you. But that's, I mean, we're down the right path, which is strings have methods like split, array has others. What are some of the array methods that we saw? Push, that's correct. And how do you know that that's a method? Because you call it with a parenthesis, right? The parenthesis tells us that it's a function. And then we have, so function and methods for us at this point are mostly interchangeable terms. We'll see that methods are functions that are attached to a specific thing, like an array, right? Where we have the functions that we have been writing currently, they're independent of everything else. Methods are functions that are attached to a specific thing, like an array. Okay, so we have a refresher on what callbacks are, and that is really important for array methods because guess what? Array methods are higher order functions. And that means that they are functions that, or methods that expect a callback in its arguments, right? So some of those methods that we're going to see today is for each, map, filter, reduce, and every. So, okay, let's jump into, actually I wanted to draw a parallel before we move on. So do we remember that we had a function, we wrote a function call for each, right? Let me see if I can grab that from the callback. We wrote a functions for each, I think, for each element. I'm going to go back to, so here I am, again, I'm following the organization that I suggested you to follow. You don't have to follow it, but again, it's just a suggestion. So here I have in week 4, I have a function, or a folder called callbacks. No, I don't want to go to callbacks, I want to go to array methods. And here I'm going to create a file called arraymethods.js, where I'm going to be experimenting. So now I'm going to open that with code, and I should see it here. Okay, so I'm going to paste my function. Oh. We have the for each element. I'm going to remove a couple of things that we had here because we had modified it. We had something like this. What does for each do again in this case? We have 1, 2, 3, and we call for each. For each element, then we are passing in the array, and I'm going to pass in my callback function, and it's going to be an ES6 anonymous function. That function, we can see here that for each element is going to call it with each element, right? With array at index I, and I is going to be changing, therefore we'll have the effect of calling callback with every element. So I'm going to do I'm defining my anonymous callback function in here. Going to say console.log element. So this was our for each, the one that you use for the callbacks assignment. Is receiving an array or is expecting. In JavaScript, functions always expect. You pass in, you have to make sure you meet the function's expectations, right? Because if I call for each with nothing, then I didn't meet the function expectations, right? Function is expecting 2 arguments, array and callback. JavaScript, when you don't meet JavaScript expectations, it goes bad, oftentimes. Okay. So once I run this program that I have here, what should I see in the screen? Malik, what do you think? 1, 2, 3, right? And why? Because it's running through the array and console logging or calling the callback for each element in the array. And then what is the callback doing? The callback is just console logging the element. So let's make sure that I'm not lying here. Node array methods.js 1, 2, 3, right? So it turns out that this is a pattern that we use in JavaScript quite often, which is iterate over the array and do something for each element. So when JavaScript, or the creators of JavaScript and the ECMA standardization body sees that this type of patterns, what they do is they take it out, or they build it into the language, so that, because it's so common, developers are doing stuff like this every day, that again, the guys that are in charge of building JavaScript say, let's just add that to the language because it's used every day. Let's have the developers write less code so that they're more productive. So that's exactly what they did in something like this. And they gave us array that for each. So instead of calling this here, so let's back up for a second. Here we have a function for each element that I, the developer, define, right? And that function is expecting the array and a callback, right? So let's see how they change the language so that, because again, this is such a common pattern of looping over the array and calling a function on each element, that they decided to build it into the language. And then thanks to that, we have something called array that for each, right? So we saw that array dot push, this is a array method. And array.h is also an array method. We know because of the parentheses, right? And so for each, let's look up the documentation. When in doubt, always go for the documentation. For documentation like this, I will search like array for each JavaScript. And again, there are 2 good sources. MDN, the Mozilla Developer Network, and the W3 Schools. They both explain the same information in 2 different ways. One is more technical than the other. In fact, something that I found really helpful when I was a fellow was to actually look at both. Because one, like W3 Schools, will explain in a more basic way. And in the end, we'll explain it in a more technical way, and that really helped me acquire language to describe JavaScript better. So let's do that. Do JavaScript array for each method in W3 schools first. We are shown an example, but let's jump to the definition, and we're just gonna see the example later. So we have definition and usage. The for each method calls a function once for each element in the array, in order, right? The function is not executed for array elements without values. Oh, this is cool. This is something that I had forgotten, that reviewing the documentation, they reminded me. So if you have empty slots on your array, the for each is not going to be called on that element. This one is kind of a good sign. So for each method calls a function once for each element in the array. That is technically exactly what we have here, right? We're calling a callback for each element in the array. Again, because that's so common, the people in charge of writing JavaScript say, let's just build it in so that people don't have to write it again and again. So, okay, so let's look at calls a function. Okay, but we don't know what function is going to call. Let's keep scrolling down. Here we have syntax. Also, practicing in trying to decode what this means is really going to help you. It's like reading documentation and being able to understand the documentation is a skill that you can acquire, and it's going to help you tremendously. Because once you learn another language, the documentation is going to be very similar. It's going to have stuff like this that explains the syntax, notes about the stuff that you will be using, etc. Okay, so here we have, so W3 School is telling us you call array that for each, and then you're calling it because we have the parentheses, right? And inside of those parentheses, we seem to be declaring a function with the function keyword of ES5, and that function seems to be expecting current value, index, and array. Okay, so this will be the first argument to the for each function, method. The second one is something called this value. Okay, let's see if we can find more information on what this means. So parameter values, this show us what for each is expecting. So the first thing is expecting a parameter called a function that is going to expect value, index, and the array. And it says is required. So we have to include the callback function, right? This function is going to be the callback function, the function that we passed to for each. Right, required a function to be run for each element in the array, and now it tells us what the arguments to that function are going to be. So what are we going to be passing into the callback? To the callback, we're going to be passing something current value. That one is required. The value of the current element. We are going to be expecting also an index. This one it says is optional. The array index of the current element. So it seems like we can have the value, and at the same time, if we include the index argument, we'll have the index of that element. And we have ARR optional. The array object the current element belongs to. In this case, we can ignore the third one because we will know. Let's look at what this will look in practice, and then maybe we can get back to why we can ignore array here.
Quick question.
Yes.
Like that is it has to use like this function, right?
Yes. So Sharar's question is it better to use array that for each than writing your own? The answer is yes. But you should still, if you have the time and want to put and learn more, you should like we did with for each, you should write your own. Writing your own for each, which we did in the callbacks lab, teaches you a lot. Like you are, with the knowledge that you currently have, you now know what for each is made of, right? What the inside looks like. I cannot stress enough how useful that is, especially once we get to think, oh, how much time is this function taking to run? And then if you know how for each works under the hood, you're able to answer that question. We're going to see a teaser of that this Wednesday on the DSA class, where we're going to be looking at something called the big O notation. That is all about how do we measure our programs, how do we know that they're efficient, how do we know that they're inefficient. But more of that on Wednesday. Okay, so array for each. Let's look at this one here. So we're not going to be using our own. We're going to use the built-in one. So again, we saw here that array for each expects a function, callback function. That function, I'm going to be defining it here in the ES6 syntax, anonymous callback. Maybe we could, actually, let's do it ES5 first, and let's do it outside first. And then we, kind of the way that we, on this one, we did anonymous function defining the parameters. But let's do it first ES5 outside to have a better clarity. So, okay, so the function that array for each is expecting is a function that will receive current value, index, and array. And then we saw that that function only requires the current value. The index is optional, the array is optional. So I could write a function that will receive the current value as for each will be looping. But let's try to see a good name for this function. Well, what do we want this function to do, right? In this case, let's just have producing the exact same result that this one was doing. And what this callback was doing is just console logging the value. So I'm just going to call it function log vol, right? I'm going to do parentheses, curly brackets. And again, I'm defining here the callback, the function that is going to be passed to for each. According to the documentation, only recurrent value is required in the arguments or parameters. Here I'm going to say, okay, current value. I'll do it current element, right? Or current value. Those two will work. The only thing that this function is going to do is just console log current value. Current element as I name the argument. Okay, so log vol. Now I define my function. If we only look at this, we don't even know if this is going to be a callback function, right? This is just a regular function. What makes it a callback is passing it down to a higher order function. So I'm going to do that here because I know that for each is a higher order function. So I'm going to do log vol. So we have this. We went from, let's take this here. Here we went from 11 lines of code to 3 minus 8, 5, 2, 4, 6. 6 lines of code that will do the exact same thing. But don't trust me. Let's see if JavaScript does it. Still have 1, 2, and 3. Right? I have saved my file. Everything is correct. So Any questions about this? Douglas?
Mine's giving me that font, or I'm sorry,
Uh-huh.
not fonts.
Do you have array that for each?
I do.
So, any other questions? So what does for each do? Say that again, a little bit louder. Okay. Somebody else, what does for each do? This is a question that you could, somebody kind of testing you on your familiarity with JavaScript could ask, like, what does for each do? Yes, William. So Vernil says it loops through the array and it performs an action for each element in the array. How could we? That's correct. That's essentially what it's doing. How could we use? What could we change perform an action for in that description? Peter? Yes, it does that, but for this case, how could we? When it said it performs an action for each element in the array, and that's fundamentally correct. But what would be more accurate language yourself? It applies the callback function to each element of the array. That's correct. We could also say it calls the callback function for each element to the array, and it passes each element of the array to the function, to the callback function. Yes. Say that again. What? If I had two parameters here in log ball, right? So in this case, the second parameter will become, according to the documentation, the index. So let's say we want to console log not only the element but at which index it is. We could use a second parameter here called index. And then I could say, okay, console log the index followed by the actual element to see where it is. Now we have the index 0 contains element 1, index 1 contains element 2. So here, the arguments to the callback function are dictated by the higher order function. The higher order function, in this case, for each, decides what to pass into your callback function. And all of that information is in the documentation. Nothing is magic in JavaScript. So we have the index, and I wanted to, let's see if we can find the major difference between the for each element that we wrote and the one that is built into JavaScript arrays is that, well, for one, this is not attached to any array, right? This is a function that we defined. It was in ES5, and it's expecting two arguments, right? Array and the callback. But in the one that we have built in, we only need to pass the callback. Why do we think we only need to pass the callback? Any speculation? Yes, Sergio? That's correct, because we already say this is the array that I want to loop over. In here, we're saying, you remember when I said array methods are methods that are attached to something? Well, that something is the array. In this case, our function here is not attached to something. We could think, without going more technically, we could think this function is not attached to any particular array. But now this for each function is attached to this array. That's why when we say array.forEach, we only need to pass in the callback, because this is going to be the array that we're going to loop over. Does that make sense? Or it doesn't have to make full sense, but at least an idea as to how we don't need to pass in array here again. Okay. Yes.
I'm going to show how to do the same thing with the function.
With which one?
I'm going to show the same thing that we can do with the function.
Oh, thank you. I almost forgot that. So right now, I define my function log wall. Is a name function is ES5, but I want to be cool, and I want to write ES6 because ES6 is cool. So how could we write this function in an anonymous function in ES6 and write it in the parameters that are going to be passed to for each? This is a named ES6 function that will be used as callback. But now I want to do ES6, and I want to define that ES6 because, again, let's revisit the motivation for anonymous ES6 functions. Who remembers why we will want to write ES6 anonymous functions? Douglas?
Because they don't get voices. No,
They don't,
they don't.
but I think you might be around the right line of thought. Char? That's the main point, yes. So Char said because we only use them once and because they're small, right? More importantly is that we're only going to use them once, right? Generally, we want main functions when we plan to use them a bunch of times. If we know that we're only going to use it once, we could just go for an anonymous ES6 function. The second reason for that, but not as important, is that ES5, ES6 functions, anonymous functions, are generally smaller. They don't have a lot inside. So it just makes sense to write it in one line, even most of them. Okay, so let's write an ES6 function here. So remember, ES6 is just the same thing, but in a different syntax. So we have to write this exact same function. So how do we write ES6? So let's do the parentheses first, the arrows, and then maybe the curly brackets, because we want the curly brackets. So okay, what is this function expecting in its arguments? Current element and index. So I better use those here as well. Also, remember that current element and index are, you can name them anything you want. These are not names that you have to keep going. Once you are familiar with for each and with for each, basically you could write this as just E for element or EL and index just I, because you and other developers that understand JavaScript and understand how for each works will know that for each passes in the current element and the index to your callback function. For now, I'm going to be more explicit. Current element and index. So okay, so this ES6 starting to take shape. Now we have our arguments or parameters. Now what do we have in the body? We just have the same that we have in the body of this function, console log index and current element. So now instead of passing my function log ball, because I know that I'm not going to use log ball ever again, I just define it as an ES6 function with the fat arrow. And now if we execute this, we should still see the same. We are declaring an anonymous ES6 function in the arguments to the for each higher order function. Yes, Malik? A little bit louder. This one's? This one, the one at the end. Malik is asking, what is the purpose of this parenthesis at the end? As we can see here, my text editor, when I highlight that one, will match the opposite or the opening one. In this case, you can see that this one is highlighted. So that open parenthesis or this closing parenthesis is just closing the arguments parenthesis. So in here, you remember when we had the previous version was array for each log wall, right? So this closing parenthesis is just this one. It's closing in the arguments to my function. Does that answer your question? Cool. It's just that because our ES6 anonymous function is being declared in the arguments, that this might confuse you, but this again is the closing parenthesis of the arguments to for each. And then this curly bracket is the curly bracket to the body of the function. Okay. Any questions here? So for each, again, it executes callback function, it evaluates callback function, it calls a callback function, it invokes a callback function for each element of an array, passing in that element of the array to the callback function as current element. It also passes in the index if we wanted to, if we needed to. Again, this is all in the documentation when we read about for each. Let's see if I missed something. Right, so let's think about, I guess a real world example was the one that we saw here, which is console logging all the elements. Who can give me another example where I would like to run a for each? Owen? Right, so if I want to time, let's do that one. For that one, I don't need the index. Time, what Owen said was time the current element by 2. Let's see what we have. Right, in this case, we multiply the current element by 2 and then we display it, right? But we're not really, if we console log array is still 1, 2, 3. It's just the display value that we're seeing is the element multiplied by 2. But another example that maybe could resonate with you will be, yes, Owen? Say that again, a little bit louder. That is a good point that I forgot to mention, which is your callback function to the for each method doesn't need to return. And in fact, if it returns, for each will just ignore whatever is returning. Like in here, if we do return, actually, I think this was a question that I had gotten earlier as well. Let's see. Let's also console log current element. So now we're console logging and trying to return. We see just the exact same thing. The return, in this case, doesn't do anything with in the callback function that is being passed to the for each. We're gonna see next what if we wanted to keep the result of multiplying the current element by 2. What if we wanted to actually keep that value maybe in another array? So in this case, the callback to the for each function doesn't need to return. For each is not going to do anything with the return value of the for each function, of the callback to the for each function. So I was going to mention that another use case for each will be, do you remember the workshop on Saturday where we asked you a very challenging question? Create a list, an HTML list. Write a function that creates an HTML list, right? You could use for each to loop over the array, right, where you have your elements, and then for each one of those, you want to call document that create element UL, right? Actually, LI for list item. So that is another good example of for each, where we could create list items from an HTML list, or rather, list items for an HTML list based on an array. We call the array where we have the list items that we want. We do a for each, and the callback that we pass into the for each will just create the element for us. Okay, and kind of connected to what I just said about HTML list and what Owen said about the point about the return statement is something that I want you to have or be aware of, which is for each. The for each method in arrays are mostly used for side effects. In this case, the side effect that we have is console logging, right? Console logging is going out and actually printing stuff to my screen, right? And in the case where I mentioned that we could, for each, could just loop over the array and create an HTML list item for each one of those elements, that will also be a side effect, because that list where we're going to be appending our list items to will exist outside of our for each of our callback function. So just keep that in your mind, that for each is mostly used for side effects, stuff that you want to perform over the elements of an array. And hopefully that will make more sense as we move along. Let's see. Again, we want to use for each. Wait, let me ask you this to you, rather. Why do we want to use for each instead of writing our own? And some of the reasons were stated here. What are some reasons that you could envision because we would like to use for each instead of writing our own? What are some of those? I mean, shorter code, yes, that's one good reason. I wouldn't say that's the more important, but we'll see another ones. Cameron?
I was going to say it takes the code longer to run.
Wait, say that again. I think it takes longer to run the code. In this case, the for each and writing our own will take exactly the same. Yep. Charles, do you have them?
Less bugs.
Less bugs. Well, what it means that we'll have less code. There's only one code that doesn't have bugs. And that code is called no code. You will only write a program that doesn't have bugs if you don't write a program. And there's actually there's a GitHub repo that it says it's an empty repo, and they advertise it as the repo with no bugs. Yeah, if you have code, you have bugs. Peter, you were going to mention something else? Okay, maybe do less.
Just because it's easier for humans to read.
Bingo. For each here, it's easier for humans to read. It's more expressive. It says, okay, for each element of the array, call this function. Right? In here, I have more code. I have more missing parts. A human will need to understand what I is, how many times it's going through. Right? We could write this to only go to half, and then the developer will be confused as to, oh, why is it only going to half, right? That's the main reason. It's more expressive, right? Easier to read for humans and less lines of code. Also, like, not always less lines of code is better. Just have that in your mind. It's better if you write code that a human understands. Sometimes when you write very short code, it's really hard for a human to understand. In this case, that is not true. We have more expressiveness here. Okay, so we have for each, and maybe as a segue, actually, yeah, now let's look at this, and then you're going to practice with one exercise. You might be wondering, okay, for each calls the function on each element, but does for each return anything back to you? Like, would it return the sum of the work that for each did? Let's look at the answer. Let's look at the documentation, because the documentation should say that as well. We are here in array for each. Parameter values. Oftentimes there's something that says return value. Return value of for each is undefined. But don't trust me or a website. See it for yourself when you do answer equal array that for each. Just try to console log here answer. So we're trying to see if the result of the for each is somehow returned back to us, and we're trying to say that to answer. See that answer is undefined, but we double checked the documentation and we found that the documentation is right. Return value of for each is undefined. So we're going to see this in contrast with other array methods that we're just about to see that do have a return statement. So two things to highlight here. One is the callback function has or doesn't have a return statement. This is the callback to the for each. Is the callback returning anything? No, that's correct. We don't have a return keyword, and we're not doing implicit return. And even if we did, for each will just ignore it, right? So the callback doesn't have a return value. The return value, or it's not that it doesn't have it, is that the return value of the callback is undefined, right? So the return value of the callback is undefined, but also the return value for each itself, the higher order function, is also undefined, as we saw here. So keep that in mind, and we're going to see it in contrast with other array methods. For each, the return value for each is undefined. The return value of the callback is undefined. Okay, so let's take 5 minutes to write a for each, or using the for each, the one built in. Write a callback that logs the element followed by its type. We did this, I think, for the callbacks array, the callbacks lab already. But now we're going to be doing it with the built-in for each. So use that for each to write a callback that logs the element followed by its type. Using for each, you could use, again, you could do ES6 anonymous definition in the parameters or the arguments, or you could use ES5 named function, or even ES6 name with console lab. So let's take 5 minutes for that. So here's an example input and output. We have this mixed array. So this is going to be your array. It has one true, an object, and undefined. And it should log the, so you're going to be writing the callback to the for each, right? And that callback should log the element followed by its type. So 1 is number, true is a boolean, curly brackets A1 is an object, and undefined is undefined. Okay, who would like to share their code on Slack so that we can take a look at? Code. Ew. Let's look at Douglas. Okay, so Douglas named his array 2. Now he's saying array 2 that for each he's declaring a ES6 anonymous function. He's expecting that function indeed will expect the current element. And then he's doing console log current element space or concatenating the current element followed by a space and the type of the current element. Let's see what we have when we do console log array 2. Let's see. Do I have another? No, not this. Let's do this. We have 1 is a number, true is a Boolean, object is an object. In this case, well, an undefined is undefined. Some of you might have seen object. Did it make any change if we do string interpolation? Like if we do a string or template literal with backticks. Let's see if this makes any difference. So I think it might not make any difference, but let's try it. Right, we still get object. Yes, Peter. So Peter is asking, why don't we see the object itself? That is because the step that happens before the console log, which is JavaScript, is seeing that we want to concatenate this string, right? But when we do it like this, JavaScript will try to convert elements that are not strings, like Booleans, numbers, objects, to strings. The thing is that conversion is, I don't want to say faulty because it's not, but it's not a full conversion, right? converting here current element when we get this object is not fully converting this, or in the term that we use in JavaScript is not stringifying this object. So if I want to do something like that, I think I can call the toString method and here. And then maybe now, oh, okay, that makes sense. Cannot read property toString of undefined. That will break on the last one because the last one is undefined. Let's imagine we didn't have undefined. Let's see. Maybe we still got the same thing. But that's a good way. Michael says we could use a comma to, instead of, right now we're passing in only one argument to the console log. We could pass in 2 arguments instead of 1. And that will look like this. So let's remove this and then like this. Now, instead of one thing that we're passing to console log, we're passing 2 things. We're passing 2 arguments. We're passing the current element and the type of. In this case, what was happening, and let's say that this works, let's put back our undefined. And even Joey put in a function, which is completely valid. You could put in, I'm going to put in my log val function in my array. So you could put functions inside arrays as well, because a function is just like any other value, like a number, like a string, like a Boolean. Let's see what happens now. Actually, I'm violating one of the steps that we mentioned in the workshop about asking questions. Who can tell what step I'm violating? It's the step of running the code at every step. Here I changed 2 things, and I'm going to see what I'm going to see could confuse me because I changed 2 things. So I'll better just change 1, which is just the comma here. Leave the function out. You want to make a change, try it, especially when you're starting. You want to make a change, try it, change another thing, try it. Don't change more than 2 or 3 things, and then try it, because then it will be difficult to identify what works when you're having a problem. So let's look at this now. Now we have a couple stuff. One is, let's look at that compared to the previous output. One is the numbers are in color, and this part is not in color. This is because of, well, the coloring is being made by console log. Console log will, under the hood, console log is also checking what type the element is, and if the element is a number or a Boolean, is going to color it yellow. If it's an object, it's going to stringify that object so we actually see it. And if it's undefined, it just leaves it grayish, and it prints it out. So this is all the console log's work. And here again, we see instead of having object here, we now truly see the object, because console log is going into my current element, and it says that if it's an object, it assumes I want to see the object inside, and then it prints it all. When we do it with the previous method, concatenating as strings, JavaScript is trying to convert the object to a string, but that translation is not complete, is not full. Yes, Alexander?
Yeah, for some reason, mine say like one says object.
In this case, and you're using the comma. In the console log in here, you're using this comma here? Okay, so that's why in this case, instead of passing in one string value, we're passing now two values to console log. Console log can receive many elements or many arguments. That will be the right word. Oh, you get it? Right, because before we were passing in one argument, which was a string, and JavaScript was grabbing the values that we were using in that string and trying to convert them to string. And then the completion, that conversion from object to string, if we do string interpolation or if we do string concatenation, that conversion is not complete. And it's a good reason because if we have a giant object, we might not want it printed to the screen. We just want to be said that we have an object there. Okay, so we spent quite some time on for each, and that's because, well, all of the others are very similar to for each. Or we're gonna see, and I hope to illustrate how they are similar and how they have sort of the same components. There's just some pieces that change. Okay, so let's move on to the next array method, which is map. So we saw, let me remove this. We have this. Let's see. Let's take our, just gonna comment this out. I'm gonna take it down. Let's comment this and this. Okay, so the map array.map method. We're going to be beginning with all array methods. They all loop through the array. That's something that they all have in common. They all go through the array. The other thing that they have in common is that they expect callback as the argument that you pass in. So they all loop through the array and expect a callback. And again, the motivation behind callbacks is modifying the behavior of the higher order function, right? So, and also the fact that we're separating, for instance, the logic that is looping over the array lives in the higher order function, and the callback is just in charge of what are we going to do for every iteration, right? So that we could we kind of abstract the loop logic to live in the higher order function, and then we use the callback to say what we want to do on every iteration. Okay, so let's draw some. Let's go back to the example that Owen suggested, which is, what if we have this array and we wanted to now have another array that is the same as this one, but where every value is multiplied by 2, right? We could do that with for each. We could do something like this. Let's uncomment this. I could have like an outside array, let's say double. It's going to be an empty array. And I'm going to say, okay, what my callback is going to do is just going to push to double the current element times 2. So if this code is written correctly when we console log double, we should see 2, 4, and 6, right? In this case, I'm using the for each to double the array elements. Let's try it. Now we have 2, 4, and 6, right? But our callback, what does our callback have now? Well, in the previous example, we also had a similar thing in the body. Say that again? That's correct. It has a side effect. In this case, our callback function is reaching out to the global scope to push the result of this multiplication into double, right? I'll say a side effect like console logging is, well, I'll say it's a necessary side effect for us debugging, right? But if I find other side effects that we actually want, I'll let you know. But most of the time, most commonly, we want to avoid side effects. In this case, the side effect that our callback function has is pushing into an array that is in the global scope. So again, because this is a very familiar and common pattern for us JavaScript developers, the people who make JavaScript said, let's just build this into the language since it's so common. And here what's common is taking in an array, doing everything on each element, and saving the result of that we did with each element. And that process is just called mapping. And in here, we could say we mapped the array or initial array to the double array. We took, well, in this case, we're still doing mapping, right? But we're not using the map higher order function yet. We're just mapping the arrays from the single values to double those values. Yes, sure. We'll see. Let's see map and let's compare. Mm-hmm. Okay, so this is how we could have ended up with the double of our array in an outside array. But again, I said we try to avoid side effects. So let's just have it here with callback side effect. Now, so since this is very common, again, we have an array and we want to execute call function on each element and keep the result of that function call. JavaScript says let's just build that into the language. So now let's look at that. So we have something called array.map. Another method, just like for each. A higher order function is expecting a callback, just like for each. And then this function is the one that will allow us to transform our array to an array with all the elements double. Okay, so let's look at what the callback function looks like here. I'm not going to write it in the ES5 syntax. I hope that one is clear by now. I'm going to do it in the ES6 syntax, right? Okay, so first, I want a refresher on what the callback of map looks like. Map, JavaScript. Oh. Java is not the same as JavaScript. Let's look at this one. The map method creates a new array with the result of calling a function for every element in the array. So we could even go do a one comparison, which is for each. Array for each in JavaScript. No, not that one. Let's look at this. This is the map. What's the difference in the definition? This line compared to this line. The only difference, there's only one. Right? It creates a new, yes, Douglas?
Oh, you were mostly there. It basically is just creating a new array to dump the results into, and then gives you that new array.
That's correct. I could have not said it better, right? This is still the same as map. Provided function, each element in the array, but we have this added thing, which is it creates a new array with the result of calling a function for every element in the array. So let's look at what that looks like. So now let's rewrite our, oh, I also wanted to see what the callback is expecting. So it seems like array map, we still have a function, it's expecting a function, we still have current value, we still have the index. Let's do it one more time. Let's look at this is called the method signature, the function signature. This tells you information as to what are the arguments and how it should be called. In this case, we can see that the two method signatures are the same, right? Yeah, it's expecting a function. That function will receive the current element, index, and array. Okay, so we saw that the signatures will be the same. So that means that my callback here, I will have current element. Oh. Forgot one parenthesis here. And now, instead of pushing to an outside array, the map function says is going to create a new array. So internally, map is going to create a new array, and is going to push to that array the result of calling my callback function on every element, right? And then there is, like the key part there is going to be that new array will contain the result of my callback function. So what's another word for result in this case? Not sure if that's return, right? In this case, we want our callback to return the current element times 2. So now my function is doing a job and or my callback function is doing the job and returning back the result of that job. And map internal is going to grab that value and add it to a new array. So, okay. Now, the documentation says map will create a new array. Where would I get that new array from or in here? Sure. So Shara said maybe we could like often in JavaScript, if we want to store the result of something, we create a variable and we say that variable be equal to the result of this work, right? In this case, the work will be the array.map. We could say let's do result equal to array.map. Do we remember? Let's do console log here. Result. Do we remember what we got when we had result, but for each? When we were trying to do the same thing, if we appended something here, let for each result. What did we get here? Undefined, that's correct. Because we saw in the documentation that for each doesn't return anything. Let's go, before we run this code, let's go to the documentation of map. Let's try to see the return value, technical details, return value, an array containing the results of calling the provided function for each element in the original array. Here, provided function means the callback, right? Okay. So let's try to run this. Oops. Identifier array is already declared. Let's comment this one out. Oh, and then I guess I need to comment this too. Try to run it. Now we have our array mapped. We have mapped our array to a new array 2, 4, and 6. So console, let's do console log. I'm gonna console log the original here. And then the result this was our original array 1, 2, 3. Now result is the mapped array, right? The array with the result of calling the callback on every element of the array. Any questions here so far? So let's see. Who can tell me a difference that between map and for each? Does that?
Map has a return value.
Great. Map has a return value, is going to be a new array. Great, thank you. Another difference. Or if, let's do difference, or what's the opposite of a difference? Similarity. Right, so let's do the opposite. Wait. A similarity or a difference? Douglas? Great. That's a good one. Somebody else? Cameron? Have the same syntax. What do you mean by that? If you could expand on that.
They all take the same.
They will. Okay, just to summarize that, they both taking a callback. Their callbacks will all take the same arguments. Mm-hmm. Anybody else? Similarity or difference? Are we missing any? I think those are pretty much it. If I'm missing one, please raise your hand. Okay. Map has a return value. It executes the callback. And then in here, let's do something that a difference here, I guess that we forgot to mention is now the callback for the map has to return something. the callback for each didn't need to return anything, and it will still be able to do its job. Let's see what happens if we skip the return of our callback to map. If we go back to the definition in the documentation, this should make sense, right? Map will, let's just go there so that I use the proper language. Creates a new array with the results of calling a function on every array element. What is the result of our callback? What is, in more technical terms, what is the return value of our callback? Undefined. That's why we see 3 undefined here. JavaScript is just doing its job, creating a new array with the result of our callback. So that's the difference. On for each, the callback may or may not return any value. If it does return a for each, we'll just ignore the value. On map, you always want your callback to return the modified version of the element that you want to keep. Here, the goal of the callback here is to take in that current element and do something with it, right? In this case, it's multiplying by 2. And we want to give that result back to the map so that the map can actually build an array with the result of the callback function. Any questions here? Yes, Lewis?
Map, you have better ways to digest an array of objects that have a lot of elements. So you can sort of map out exactly what's
right. That's correct. It will be, I think the example you're referring to is an example that is in the lesson, which is we have this array of films, right? Let's say let's copy this. Let's comment these out. So we have this array of Netflix movies, and then we could use map to get an array of the exact same objects, but now maybe with less information because we don't care about the URI, we don't care about the ID, right? We could map this array to a new array that only contains the information that we want. We could do that if we have, so again, this is an array with objects, right? These objects are representing films, movies, right? Properties and keys, or keys and values. We could, let's say we're only interested, let's say, in the title and the rating, because that's the information that we want to display on one part of our website, right? So we could do that if we say something like, let mapped films is equal to films, the array, that map. Now I'm going to write my ES6, sorry. In here, if let's do, okay, so we have the parentheses, the fat arrow. I'm going to have the curly brackets. In here, because we know that every element, or in this case, every film, every movie, is going to be passed to our callback. Instead of saying current element, I'll pick a more accurate name, which is movie. But we are receiving in every element, and what is every element? Every element is a movie, right? So I could say, okay, and I only want I still want an array of objects. It's just that now I want those objects to only have the rating and the name. So if you still want an array of objects, then you better return an object from your callback. And this object is going to only have title. So title, and then that title is going to be the movie title. And then it's going to also have a rating. That rating is going to be the movie rating. Let's do this in multiple lines so that it's more readable, so that we have every key in its own line. So right now we have our map. We're passing in a callback function that receives every movie, and for every movie we want to return only the title and the rating of the movie, right? This is going to be a new object that has 2 keys. Now if I do console log map films, see what we have. We have an array of objects. Those objects now have only 2 keys, the title of the movie and the rating of said movie. So in this case, we were able to transform every element into a more compact way that we may use, for instance, in one section of our website. For instance, when you're displaying the movies and their rating, right, for somebody to pick. But now, once you go into one of those, you show more detailed information like the art or the cover or box art of the movie, right? Because well, I guess you could also show that in when you're picking a movie. So in this case, we were able to map our original films array to reduce or more compact way, or in a more compact form here. Kind of getting rid of the information that we don't need at the moment, or we may not want. Another point to highlight here is map will always return an array of the same length as the array that we're calling it on. So if we have 4 movies, we get 4 movies in the output array. So let's see if I have an exercise for you to practice. Oh. So one point that I want to make here is the callback for the map is what dictates the transformation or the mapping that is happening to every element, right? In here, the callback is the one that dictates the transformation that will be done to every element. And also, so why would we prefer map over for each? Pupil? Yes, I would say that could be a more complete answer, but you're down the right lane. Douglas?
Does it save us from having to make elements specifically for this?
I think you mean this is saving us from creating a global variable?
Right.
That's correct. And that's basically the why we will prefer map over for each. Map and the callback of the map doesn't have any side effects. It's not going outside to the global variable to add elements to that global variable. Map is self-contained. And this is, again, a demonstration of how oftentimes we, or most of the times, we don't want side effects. They made map to not have a for each with side effects, so that map indeed doesn't have any side effects. Any questions? Owen?
I'm just wondering why we have to set it to a variable. With the time.
This part, right? Why do we save it to a variable? I'm gonna let one of your classmates answer that question. Why do we want to save it to a variable? I mean, yes, but maybe a more, let's see, sure. Right, it's because, well, the map will return an array, and where are you going to put it? How are you going to name it? Yes, Brianna, did you have it? Okay. So we have map. Map has a return value, right? Map does some work, and it gives you back that work for you to use at a later time. And in that case, we want to put the result of that work in map format. Oh, does that make sense? Right, we map, again, we want to save the result of the work that map is doing. Okay, any other questions? Joanne? The same applies. It is expressive in the sense that we're indicating we have an array and we want to map that array to another one. Any other questions? Yes, Douglas?
So if you're using for each, you can count results the same way that, like, in the exit ticket, you have the one I continually changing its error line to give it twice, lines 2 and 3. We could do that the same way, where you could run it for 2 different lines to affect the same counter.
I'm not sure I understand your question.
Could you run 2 variations of a, like, if you're building a graph into a built a global array from for each, you build 2 different for each functions. Where not functions, yes, 2 methods where you're doing for each calls that are affecting the same line.
You could end up with the same case that we had in the exit ticket, which is, but you're talking about a for each that has a side effect of modifying a global variable. Is that correct? Yes, you will end up with the same case where you could have 2 for each, and because the callback of those for each is reaching outside, when you console log, let's say the array where those for each is putting its work, you will see the modify version by the 2 for each. Yes. Okay. I realize that I've been getting questions from the same people over and over the course of the night. I want a question from somebody new. Let's see. Do we have a volunteer that may be wondering about something? Right. But actually, thank you, Jar, for that. I will make sure to be prepared next time because it takes some time to set up. Let's see. So I guess I'm just going to pick someone from my brain, from the algorithm that I'm running on my brain. Let's see. Jonathan, do you have any questions about this, or maybe something that you would like to clarify? Actually, call that. We have a new question from Deja.
When you're doing
That's a good question. Deja asks, can we skip some elements if we don't want the function to do the work for certain elements? We cannot skip per se. What we could do is just have, instead of, well, actually, let's see if this makes sense to you. We wouldn't skip in the sense that we're not going to have, let's say this array, the array of films has 4 films. Let's say we only want 3 or 4 of them to be the modified version. If the new array will need to still have the same number of elements that the original array had. So a map cannot use a 4-element array to give you back a 2-element array. It has to, it will return to you back the same elements. You could choose to keep doing the work for a given element. However, let's say we skip doing the work for bad boys here, right? So if we keep doing the work here, what we're going to do is not that we're not going to have bad boys. We're going to have bad boys, but with all the rest of the information. And then that is really like I think I have never had objects in an array that look different, like greatly different. And if we had bad boys look like this in our output array, bad boys will look significantly different from the rest. Right? Mapping is mostly when we want the same transformation being applied to all the elements. Jonathan, do you want any clarification, questions? Uh-huh. My advice for people using ES5 will be keep doing it until you know the in and outs of the ES5. And then once you realize that you are at that point, switch immediately to ES6. ES6 is the new standard. It's probably the code that we're going to be seeing from here on is ES6. And there's not huge difference between ES6 and ES5. The biggest difference is function declaration, constant let. So yeah, do that until you feel comfortable. After that, switch to ES6. Mm-hmm.
Really adding to that, another good thing about that, whenever you have to do a function, right? Write one in the ES6 and one alternate between them.
That is better advice than the one I gave, which is because that will actually force you to think. If you're fairly comfortable doing ES5, will force you to think, how would this look in ES6, and it will make you learn faster. Thank you for that. Okay, so we saw map. Let's see if I have it. We saw why we would want to use map instead of for each. It doesn't have any side effects. Oh, I wanted to. Actually, let's take a 5-minute break. That has been quite a bunch of content. Let's be back here at 9:21. Uh-huh. What do you mean?
I was wondering if you could use conditional.
Uh-huh. But the JavaScript.
Yeah. So I will make a copy and put it on slide.
Oh, you mean like you still have an outside variable, right?
Yeah, but I don't use that. I use the new one. So I did that slice, and then I use that for each. And it creates a new one. I was thinking instead of having the body, Like instead of having this.
No. So you're making a copy of the array with slice, right?
Yeah.
And you have array 2 for each. Okay, right, but this still has a side effect, right? What's the side effect here? This array 2, right? Array 2 lives outside. Your callback is reaching outside.
Isn't that part of that?
Of this one? Yeah, so actually yours is dangerous.
It modifies the array.
It modifies the array, but at the same time, this could give you, I feel like, weird results because it's modifying the array. Oh, this is an interesting case. Let's try it. It's looking over the array, but at the same time, it's modifying it. So you could end up with an infinite loop where, let's say, this is instead of slicing, it's pushing. Then
I tried it with this, it worked. But I don't know.
Right. I mean, it works.
Well, what I want to know is that we could just change the return value and put a condition.
Right. So here, what are you doing? The splice is this is where you want to splice, and this is you want to remove one, and then you want to add the element times 3.
Yeah.
But you're not getting out. And you're getting. I see. Okay. Makes sense. Right. In this case, because you're removing and now adding 1.
Yeah.
Huh. This is interesting because. Right. If you remove something else, you. Oh. I was expecting, what if it does the multiplication and the for each moves to 1 that was already modified? And then it tries to do the same again.
So put a 1 or put none.
0?
Yeah, put 0.
Right. We're not removing and
Still stop.
still stopping. That's true. Right, it's still stopping because, well, it's removing 0, but the loop is only going
9 times. Okay.
9 times.
So it takes in the array 9 times.
So, yeah, this works. It's still, I mean, still kind of hard to read.
Yeah.
Kind of, okay, it's for each, and then it's splicing the array with.
Well, aside from that, I tried doing something else, right? I tried putting that in a conditional and then trying doing it if it's even.
Right.
If it's even, it's not. Don't do it. But I was having trouble with it.
Right, because then you're modifying array 2. Yeah, the only way would be just to, again, in here.
I was thinking about my filter, and then when she asked that question, I'm like, it's a good filter.
That's what
For her in one shot.
Yeah, in this case, you always need a side effect to be able to do it. Okay, let's keep going. Okay, welcome back. The next method we are going to see, map. The next method we're going to see is something called filter. And Deja, this is one that where we can actually accomplish what you were saying earlier. Okay, cool. We could actually leave some elements out based on a test that we perform. So let's go back to the documentation. Let's see what we find. Array filter JavaScript, W3 schools. The filter method creates an array filled with all array elements that pass a test, provided as a function. Note, filter does not execute the function for array elements without values. Filter does not change the original array. Is this a note that we saw on map as well? I think we should have seen this note on map. Right. Map does not, no. Yeah, no, this method, or map, does not change the original array. What's the method that changes the original array? Splice. One more. Starting with a P. Push, pop. Those array methods are mutating the original array. Map returns a new one, a new copy with the new work, with the result of the work. For each, we'll just call the function returns undefined. Now we see here, filter does not change the original array. It, similar to map, it creates a new array. But now instead of that array containing the elements or the result of passing the elements through the callback, here we have that filter will create the array filled with the elements that pass the test, that pass our filtering. And here in parentheses it says the test is provided as a function. Let's see what that means. Let's keep going to see it here. Let's look at the signature. Still identical to map for each. Array, the name of the method, a callback function, expecting current value, index, and array. Let's look at the parameters for that function. Well, so the parameters for the filter is the function is required. And then it says about the function, it says a function to be run for each element in the array. Okay, well, that was the same that it said for each and map. And then it says the arguments that are going to be passed to this function are current value, which is required, the value of the current element. Nothing changed here, nothing new. Let's see the return value. Return value, an array containing all the elements that pass the test. If no elements pass the test, it returns an empty array. Okay, but this is still not saying anything about how do we write the test. Okay, then it gives us an example. Okay, so this is for instance 1, where it's not exactly clear how we will write the test by the W3 documentation. We could derive how we write that test by looking at this example. I want to see if the MDN actually says something about how we write the test. Array map JavaScript. The map methods creates a new array with the result of calling a provided function on every element. No, I'm sorry, I meant the filter. You were going to allow me to go there, didn't you? The filter method creates a new array with all the elements that pass the test implemented by the provided function. C. Callback. So in here we get the same array, the same method signature. The only thing that differs here is, let's look at this. Here, in the end, here, the W3 scores. So this is the same as this one, this part, right? Array.filter. The only difference is in here, function, instead of saying function, like W3 says, it says callback. Now we say that that callback is being invoked by the parenthesis. We'll receive an element that is the current value. And MDN specifies these square brackets for index and square brackets for array, because square brackets here means optional. It's just a more concise way to say element or index is optional, array is optional, this art is optional. So in essence, they're basically the same. Let's see. So parameters, the callback function as predicate to test each element of the array. This at least gives us a little bit more information, which is function as a predicate. That's still a little bit confusing. But it says to test each element of the array, return true to keep element, false otherwise. It accepts three arguments: the element, the current element being processed in the array, right? That's the current value here. Index, which it says is optional, and array, which it says is optional. But this one gave us more information. This one says the callback has to return true or false. It should return true if we want to keep the element. It should return false if we want to skip it or disregard it. Let's see. Does it say? Let's read the return value in the array with the elements that pass the test. If no element pass the test, an empty array will be right. Okay. So we learned that the callback to our filter method has to return a Boolean true or false. Based on that, filter will decide to keep the element or not. So let's look at what that actually looks like. So let's use this array that we have here. We have this array. Now I want to filter this array to leave only the even numbers. I think you did this for the callbacks lab again, where you wrote a function with that receives an array and a callback, right? And then it returns back to you a new array with only the even numbers or the odd numbers. So let's look at what that will look like using the dot filter. So same deal. We have array dot filter. I need to make sure that I don't have another array declared somewhere else. Okay, we're good. Array dot filter, higher order function, is expecting a callback. That callback written ES6 will be current element. Arrow, body of the function. Now, the documentation told us we need this function to return true or false. And if this function, filter is saying if this function returns true, I'm going to keep that element. If it returns false, I'm just going to skip it. So now we're trying to filter by see if the current element is even or odd. How can we test for that? Giselle, a little bit louder. That's correct. We can test that by doing element modulo 2 if it's equal to 0. Okay. Do we want this in an if statement maybe? Maybe we could say if the element is even, then return true. Otherwise, return false. right? Now our function, if for, again, filter will call the callback function on every element. So that means that it's going to call it for 1. It's going to see if it passes this test, current element modulo 2 equal to 0. In case we have current element equal to 1, that is false, then we return false. Now we have 2. Current element modulo 2 equal to 0. True, we return true. Let's see what we have when we console log. Oh, what am I missing here? Or, I mean, right, so I want to save the result of the work of the filter in another variable, right? Filter, we saw here, return value, a new array containing all the elements that pass the test. So we have, right now, I'm having my program do the work for filter, where I'm just like doing the work and throwing that value in the air. It's just going to be lost. If I want to keep it, I do, let's call it filter array equal to the result of the filter. Filter array. Let's execute this. Node methods. And we have indeed a filtered array now. Yes, start here. That'll work, yes. Because, well, this condition returns true or false. So what Sergio is suggesting is, and that is correct, we could get rid of this if statement and just say return current element modulo 2 triple equals 0. This will still work. Why? Because, well, this expression that we have in parentheses already returns true or false, right? So in this case, we will be a little bit redundant on saying return true or return false. But I still wanted to do it this way because this might not be very familiar to us yet. Right? Yes, Joanne. In this case, if we have the if statement, the else is not strictly necessary. But why? That'll be the question. Here we could, let's see if that still works. Still works. If we had the if statement, the else would not be necessary. What does our function returns when the if statement is true? If the if statement is true, if this if statement is true, what do we return? True. We just return true. What happens if it's not? If this statement is not true, what do we return? I think I heard it. Nothing and undefined more explicitly. And undefined is that a truthy or a falsy value? Undefined is a falsy value, so it's interpreted as a falsy, right? So if our function, when our element is not evenly divisible by 2, we return undefined. Filter assumes undefined as false, and just decides to skip that. Yes, Douglas?
Just making sure that if I'm defining our array with something else, it's not AR1. Would that also be reflected in the structure?
That, if we had, let's say, in this list of movies, we could filter. I'm only interested in movies with rating 5 because I only like the best movies, right? So I could filter this array for movies that have the highest rating as well. Before we go into there, let's see. Okay, so we saw that this one was, we could just remove this if statement and just do with the result of this expression. And if we do this, then we realize that our filter could just fit in one line if we use ES6 implicit return. We remove the return keyword, we remove the parentheses, and we have a filter that takes in callback function all in one line. Right? This function can be so tiny that it can be done in one line. We have still get the same thing, right? And here was using the implicit return of this ES6, right? I'm going to get it back to where we had it. I'll leave this here. Okay, so I'm going to give you 5 minutes to using the films array, which is in the actually I think the solution to this might be in the lesson, which is filter out the movies that are less than 5 rating, the 5 in rating. Let's see. I think it is. Yeah, it is here. Let's just look at how. In this case, we're doing the filtering, but with the for each. We again see that, and the lesson is demonstrating here how we could sort of filter with for each, but we still see the downside of that callback function having the side effect of reaching out, right? Then using the filter method, we have this part, the best films IDs. Well, this one is only doing the IDs. Films that filter, let's take this one. Let me comment this. Comment on this thing. So best films. In this case, this might look like a weird function, right? But if we look carefully, this should still make sense. So far, I've been doing the filter like on the same line here, array.filter. But it turns out you could do it in a new line like this as well. You just have films, and the dot filter is just like in another line, but JavaScript doesn't care about this case. It will understand as it's just films that filter. I still prefer to have them on the same line and have this match that, and have this only one level of indentation. So again, filter goes over the array, passes in every film, in this case, to the array, to the callback function. And then this callback function is implementing a test, which is check if the rating is equal to 5. If the rating is equal to 5, I want that movie because that's one of the best movies, right? Here, in this case, we see the same thing, that we don't need the if statement. We could just say if return film that rating triple equal 5. This will, if we have this console log best films. Oh. Now we have an array filter that only has the best films, as Bad Boys and Fracture, right? Any questions about filter? Are we seeing how we're basically doing the same thing, which is loop over the array, execute a function for every element in the array, and they differ in what they do with the result of executing that function. Yes, Peter? Good question. So what if we only want the title of the best movies? In this case, yes, I mean, we could do mapping. But the question is, like, why wouldn't we be able to do that with filter? Like, let's say we only want the title of the best movies. We don't care about anything else. And like, why wouldn't we be able to do that with a filter? Savita? It's a little bit louder. Filter requires a condition. I think you have the right idea. It will be the callback to filter returns a Boolean. It returns the result of a condition, right? And that's all it does. They will take that result of that conditional, and if that callback returns true, it keeps the element. Otherwise, it skips it. In here, filter doesn't allow us to modify the element, right? The way that map does. The callback to map allows us to modify the element, right? We were able to take stuff out of the movies array that we're not interested in. But the callback to filter doesn't allow us to modify the element. Yes, Peter? That's correct. So if we wanted only the titles, we will need to map our best films. Let's do map best films equal to best films dot map. Oh, also you might have noticed that this one, the callback here to film to the filter doesn't have parentheses surrounding film. I have been putting them in here, for instance, current element. See the callback? Yes, Savita? The parentheses that we're using here? Okay. Yes. So with filter, we could filter elements out based on a condition that we establish in the callback function. So the callback function is the judge that says of a filter, is the judge that says you may pass, you may not pass, you are not allowed. In this case, the callback to filter returns a Boolean, true or false. Now, filter is going to use that Boolean to decide what elements to keep and which ones to skip, right? The callback to filter doesn't have, is not allowed to modify the, element. And I'm just thinking as I'm saying this, that there might be a way in which we could do that, but it will not be standard code. It will be something that, because of some weird facts under the hood of JavaScript, will allow us to do that in this case. But so the main point is the callback to film receives the element, but should return a Boolean, and it should not modify the element that it received. Right? Now the callback to map, the whole goal of map is to modify each element and save that modification to a new array. Right? So and that's actually what we want here. We want to modify each element of this best films to contain only the title, or maybe we don't even want the title. not that we don't want the title, but maybe we don't even want the title in the object. We may just want the strings of the best titles. But so again, why isn't it possible to do it with filter is because filter receives the element and has to return true or false. Map receives the element and it has to return the modified version of the element of whatever transformation you want to make. Does that feel a little bit more comfortable? Sergio? Yeah, Savita? But how do you feel about with that explanation? Yes, and map is like map. I cannot filter with map, right? Mm-hmm. So you.
So you only want it and title.
Mm-hmm.
And you just build
Yes, I'll need to use map as well. So let's do that here. So we only want the titles, and let's have objects with the title. So that will be film here. Oh, so the point that I was making earlier is when you have an anonymous callback function, an anonymous ES6 function like this, and that function only expects or only receives one argument, I could skip adding these parentheses. Adding these parentheses to indicate where the arguments go. So again, if I add them, there's no problem. But if it's one argument, I could just skip them. JavaScript is able to understand that. What this feels a little bit weird is the fact that if this function, imagine hypothetically, it didn't receive any arguments, we will need to include the empty parentheses. But that's sort of a side note there. So let's go. We have the best films, and this is like not even the best film IDs, just the best film. So now we want to have only, yes. Thank you. Now we want to only have the titles. So we saw that the callback to map has to return the modified version of the element, right? With the transformation that we want in the element. So I'm going to do return. I want to return an object that only has the title of the movie. So I'm going to do film that movie. No, film that title. Now let's console log instead of best films. Are we clear with that best films is the filter version of the films array with only the movies that are rating 5, because that is the test that our callback was implementing for the filter. After that, we want to only have the titles. So we're mapping the best films and returning for every one of those a new object with the title, and that will contain the film title. So let's console log here, mapped best films. Now we have an array with 2 objects that only have the title, right? I was able to remove some of the extra information with the map. I mapped my best films from an array that had object with all these properties to an array that has only one property, that has the same 2 objects, but now with only one property. Any questions about this? Yes, DR?
So, like, right after line 92, like, we put map in there, map.
Right, so what JR is saying, could we write map here? What do we think in general the answer to that is? Thumbs up if you think yes. Thumbs down if you say no. Okay. So the answer is yes, and let's see why. We can do map on an array, right? We know that we can just say array.map. And then let's think about what is the return value of this? An array. So I could literally say here, let me comment, comment this out. And instead, actually, not comment, let's just do, I'm going to take this map from here. I'm going to cut it and paste it here. Let's see what best films have now. It has our filter array, and right after that, we did the map. So it has our filter and map array, right? The two operations. This is called, or known as method chaining. We're chaining the filter and the map methods. And this is possible because of what we said. Filter returns an array, and we just, right after filter returns that array, we just map over it, and then we save all the result in best films. The way we were doing it earlier, let's see it kind of both ways. The only difference that we had before is that I was storing the result of the filter in best films, right? And then I was using best films here to do the map. But if I wanted to, I could still do it in just one, or not in one line, but by chaining the two methods, filter and map. Is that clear? How does that feel? Okay, some thumbs up. Again, if you realize and feel inside that you know that filter will return an array, then you could just change that map to the array that filter will return. Any questions here? So in this case, when we do this, we have still valid JavaScript. Yes, Brianna? Mm-hmm. That's correct. Mm-hmm. Well, most of the time, it will give you a modified version of the object or a modified version of the number. Or for instance, I could do a map. I could map an array, the mixed array that we have here. Do we have it here? I think I removed it, but I could map, for instance, we were doing it for each to log the element and then the type of that element. I could use map to map the elements to an array with their types, right? Say that again. That's correct. For instance, that's a good example. Let's say my array is mixed, but I don't want a mixed array, right? I want an array that has only the numbers of the original array. I could use filter to implement a check here. If type of the element is number, then return true. Keep it on disregard. Any questions? Any final questions? We still, this is what I'm saying, we still couldn't get to the last one for array methods, which is reduce. Reduce and every. I feel every is pretty straightforward. But please, if you didn't read the lesson, read it again. If you didn't read it, just read it for the first time. If you did read it, read the reduced part. Maybe even research on W3 schools about it. Tomorrow we're going to be working in the array methods lab, and I'm going to take the first, hopefully 20 minutes to go over reduce, so that we can go over reduce. But if you read it, you'll be much more prepared. Addie? Oh, right. Let's leave the exit ticket for tomorrow.
Also, the funny thing about the reduce is that reduce is like squeeze marginalized from like array method. Reduce can do basically anything you can do with other methods. You can replace math with reduce. You can replace every with reduce. So read through it and think about how.